So you should have out your papers for 4-4. So look and see, make sure they're in order. Section 4-4, 4-6, 4-7, and the chapter review. They should be in that order. And then you can put your test beside it. I'm going to take them up in 2 separate and pass back pages that I have. Okay. Here's your homework. So put on here the things that you're missing, okay? You don't have lesson notes. I was missing. So we look to see if you need to wait and hand it on later. Go ahead and look and see what items you need to make sure to have. Okay, I sent the email out that says everything that needs to be in homework. April,
I'm trying to figure out which ones I need to vote on.
okay, so
I have half of my. I'm honestly because I have. I mean, all the things I did.
I only have 4-3 for you. Okay. This is all that you had shown me. What about lesson 4-1 and 4-2?
I should have them in my notes. Maybe I just get more out.
Yeah, find those so I can, because I haven't been able to score it yet. So
This is 177, 42, I mean, 42.
okay, but so I need, so that's 4.1. So what we're needing is,
I need to throw things that I'm doing.
4.1 would be pages 198 and 199.
That's right. I know it is now. This is.
I'll make sure you both miss.
What?
I'll make sure you both miss this next time.
Yeah, look for those. So remember, look back at the email that I sent you that tells you everything you need to have, okay? You should have 100% on this homework, all right? So make sure you have all of your assignments complete. Make sure you are writing lesson notes. Make sure you are heading your paper and putting what section it goes along with, as well as your name, okay? We're doing odds, so you can use the back of the book to check them. When you check them, you are marking the ones you missed. However many you missed, you put minus something at the top. If you missed nothing, put -0. I need to see something at the top of that page so I know when I'm looking for corrections, okay? Then there needs to be a specific place that says corrections after that section where you are correcting the ones you missed, okay? So, like I said, if you follow this process, you will have a 100 on your homework. Lucas?
Charlie said he's in the waiting
Oh,
room.
thank you. So if you follow this process, you should get 100 every single time on your homework. So before I collect the homework, if you want another day to go through it and fix it for tomorrow, you may take it back home. If you need to add lesson notes to something, just get a piece of paper, write the notes in front of it, staple it to the front of that paper, okay? So if you need to wait till tomorrow to turn in homework, wait till tomorrow if you want to go back through it. If you have something that maybe you forgot to check and make corrections, go back and do that. okay? So I will take these tomorrow if you want to go back and check them. Today I'll just collect the test, and then you can wait if you want to turn in the homework tomorrow, all right? If for some reason you need a little more time, let me know. Let's talk about it, okay? Because it breaks my heart to give bad grades on homework assignments when I'm trying to tell you all you have to do is this, this, and this, and you're going to get 100 on it, okay? So please just it's going to be overloaded and you're not going to be able to get it done, okay? So remember, you should be working on math a little bit every single day, okay? There shouldn't be a day goes by that you haven't done something. Now, maybe you decide that Fridays are not the days that you want to do math, and maybe you do some on Sunday afternoon instead of Friday. That's totally up to you. But you should be doing on Monday and Tuesday, even though you don't have math, you should be doing a little bit of homework unless you finished it all before the next week, but don't put it off, or it's going to be way too much for you to do, especially to write the lesson notes, to do the work, to check it, and make corrections, okay? It can be a lot.
So what are the
Remember I said your lesson notes would be at the beginning of the chapter. Maybe it's a formula that they told you. Maybe it's a postulate. Maybe it's, maybe it's if an isosceles has two congruent sides, that means the base angles are congruent. If the base angles are congruent, then you know the sides are congruent. Maybe it's the triangle addition postulate. The measure of 1 plus measure of 2 plus measure of 3 equals 180 degrees. It's all those things in that section. They can be bullet points. It doesn't have to be, you don't have to draw the entire box and give all the details, okay? Let me give y'all just real quick a side-by-side comparison, okay? Eric, can I use you as an example real quick? Okay. Oh, let me see here. All right, so this is just a comparison, and Tyler, I'm using you as an example too. Sorry, bud, you're not here to give me permission, but I'm just taking it. Okay, so you can see here on Tyler's, he just listed. So like in 4.1, classify by sides, equilateral, isosceles, scalene, classify by angles, acute, equiangular, right, and obtuse, triangle sum theorem, exterior angle theorem, corollary to the triangle sum theorem. He just bullet pointed. Now Garrett drew pictures, okay? A lot of information. These are his lesson notes. He has 2 pages of lesson notes, whereas Tyler just put it bullet pointed. It is up to you guys how you do it. I just want to see you put some kind of summary at the beginning of your work so you can say, hey, in this lesson, these are the things I focused on, because this is what the homework is going to be on. Because what's going to happen is as you're doing your homework and you get to a problem that you don't know how to do, you can look right up here at the top of your page and go, oh yeah, it was this. Or if you've got the drawings, however you need to do it for you. You are all individual learners. You all learn very differently. Some people need more details, some people need to refer back to, okay? The other thing is remember to show your work. If you had an equation and you had to solve for X, I need to see it. I don't want just an answer, because the answers are in the back of the book. It's super easy to flip to the back and just write all the answers down. That doesn't show me you've learned anything. That doesn't show me you know how to work the problem, okay? I don't want it to have to be to where I start assigning evens again, and but I need you guys, this is kind of a way of learning how to take control of your learning, okay? I can stand up here and tell you guys stuff all day long, and you may or may not get it, and that's what's going to happen if and when you go to college, okay? If you're planning on going to college, then a lot of times what happens is what is in the textbook, the teacher doesn't even teach. They stand at the front of the room and they lecture, and it is your job to go to the book. Now, not necessarily math, they're going to show you how to work problems and stuff, but in different subjects, you're the one that has to go and pull out the important information. You've got to know how to do that. So that's what I'm trying to do with these lesson notes, help you know what is it that I need to know to be able to do this work, okay? I have told you in class what we're doing, and then you also have the benefit of going to the book to pull it out, okay? So it's the kind of thing your work may look a little bit different than the other, but I'm just looking for something. I'm looking for where you just listed out. I'm just looking for where you listed out what it was covered in that section. So you have a place to focus when you're doing your work. Okay. Also, remember, this is going to help you for when you move on to Algebra 2. As Claire Jane can tell you, I think Miss Steph might be a little bit harder on the homework than I am. And so, but this is the basic way that she does it as well. So if you get into this habit now, it's going to be so much easier for you if you're taking Algebra 2 with Miss Steph next year. Okay. So I really don't want to be, I'm not trying to be nitpicky and ugly about it. I'm trying to teach you how to help yourself. Does that make sense? Okay. So I don't want you to think I'm fussing at y'all or anything. I just want you, I've given you the guidelines. I've told you what my expectations are. So you know what I'm looking for. And so, and it breaks my heart to have to put down less than 100% on something when I know you're capable of it. Sometimes maybe you either just forget to do it. Hopefully you didn't just choose not to do it. But anyway, so if you want to take your homework back and fix it, feel free. Bring it back tomorrow. I will go ahead and take up the test.
I think I had a question. I'll ask for Jennifer. I have a few questions.
Okay. On both pages for me.
Like once we've already finished them, or do you go back and check it? And make
Yeah,
sure-
so that's what I call the corrections. Instead,
Okay.
she calls it redos, I call it corrections. Yeah, it's the same thing, same thing, yeah. All righty, so we'll go ahead and get started. We are going to be starting chapter 5 today. All right. Starting in chapter 5. All righty. So in chapter 5, we are starting out with perpendiculars and bisectors. Okay. So you can see at the beginning, let's see, this is on page 262. What is this chapter about? It gives us our key vocabulary. So a little hint there is if it's vocabulary, probably it's something that would be good to go in your lesson notes when you do your assignments. Just know that it does not have to be the whole definition or bullet. Okay. Are you ready for the chapter? All right. Drawing segments, drawing angles, finding coordinates of a midpoint. What is my formula for midpoint?
Is it
N equals x2 minus x1 plus y2 minus y1.
No, that's going to be my distance formula. Distance is going to be the square root of,
Isn't the x1 plus x2 over 2?
yes, we find the average of the x points, x1 plus x2 divided by 2, and y1 plus y2 divided by 2. Now remember, you can remember it as x1 plus x2 or x2 plus x1. Commutative property tells me it does not matter what order I add in, okay? So I just know I'm adding my x's and divided by 2, adding my y's and dividing by 2, okay? And then our distance formula we talked about, the square root of x2 minus x1 squared plus y2 minus y1 squared. That one does matter, but it doesn't matter which point you choose as x1 and x2, okay? So just think about that. Also, slope. What, when we talked about the slope of a line, what did we say the slope of a line is? Anybody remember slope? Rise over run. So that means, am I going up or down to get from point to point and then side to side? Okay. So now we're moving on to 5.1, perpendiculars and bisectors. So goal 1, this is on page 264. Using the properties of perpendicular bisectors. In lesson 1.5, you learned that a segment bisector intersects a segment at its midpoint, okay? So, a segment bisector intersects a segment at its midpoint. A segment, ray, line, or plane that is perpendicular to a segment at its midpoint is called a perpendicular bisector. Again, that's a segment, a ray, a line, or a plane that is perpendicular to a segment at its midpoint is called a perpendicular bisector. So the two things to remember here, think about, what does perpendicular mean? What does it mean if they're perpendicular? They intersect at what? A right angle. Right angles are equal to 90 degrees. So I've got two lines that are going to intersect at a right angle, 90 degrees. And then what does the word bisector mean? What does the prefix bi mean? 2. So I'm cutting it into 2 pieces. And because it's at the midpoint, what do I know about those 2 pieces? If something is cut at the midpoint, if it's cut in the middle, what about those 2 segments that have been cut in half? They're equal to each other. Good. So a perpendicular bisector means that it's because of lines intersecting at a 90-degree angle, and it's cutting that segment in half. Therefore, either side is equal to one another. Okay? So there's a lot of things here that we, just by knowing previous terms, we're able to kind of put these together now. So we can see here in the diagram that they gave us, where we can see that CP is a perpendicular bisector of AB. Therefore, A to P is congruent to or equal to P to B. Okay? The construction below, we can see kind of the picture below. We're not going to worry about drawing constructions, but you can see where, to be able to draw a perpendicular bisector, the first thing you would do is draw a line. And you have your points. You start at point P, and then you've got your A and B. You set your compass on one of the points and make an arc at the top. Then you're going to set it on the other point and make your arc at the top. And then that way, where these 2 arcs intersect and your midpoint is where you draw your perpendicular bisector. All righty. At the very bottom, a point is equidistant from 2 points if its distance from each point is the same. So remember, equidistant is going to mean same distance. And so you can see that when I have my construction, or when I look at this diagram, I can see that B is equidistant to P as A is to P. Okay, so they are the same distance. Go ahead and look over on page 265. It says theorem 5.1 below states that any point on the perpendicular bisector CP in the construction is equidistant from A to B. So basically the construction that they just drew is showing us the first one in the box. Now remember I had CP with a line that is intersecting AB. Notice that if I have a point C on that line, on that perpendicular bisector, then not only is it the same distance from A to P and B to P, but if I had a line up here, it's going to be the same distance from C to A as it is from C to B. If I had a point down here, it would be the same distance from one to the other, okay? So this is called the perpendicular bisector theorem. This should be in your lesson notes when you do your homework tonight. Basically, it just says if there's a point on the perpendicular bisector, it is equidistant from the endpoints of the segment, okay? So you can see the symbols that they've drawn. If line CP is a perpendicular bisector of segment AB, then CA is equal to CB. Theorem 5.2 is a converse of that, okay? So remember converse flip-flop? So it just says if a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector. So first of all, if I only have points and I have my perpendicular bisector, I can conclude from the first one that my distance is going to be the same. This one is saying if the distance is the same, then I can interpret that it is a perpendicular bisector. Everybody good with that? All right, so they're giving us a proof to look at. I want to walk through it just so we can kind of make sense of it. It says plan for proof for theorem 5.1. Refer to the diagram for theorem 5.1 above. Suppose that you are given that CP is perpendicular to the perpendicular bisector of AB. Show that right triangles, triangle APC and triangle BPC, are congruent using the side angle side congruence postulate. And then show that CA is congruent to CB. So basically in this situation, we are looking at our two triangles here. We're looking to see that CP is the perpendicular bisector. So think about if I've got triangle APC, and I have triangle BPC. Okay, with this real quick. If I'm looking at this triangle, they have told me that these two sides are congruent, right? Everybody following me so far? They've told me that this side and this side are congruent. Now, what else do I know from this drawing? What else did they not specifically tell me that I can know by looking at the drawing? 90 degrees. Okay, so I know that each side is going to be 90 degrees. All right, Healy, I'm going to put you on the spot, hon. This is something we talked about yesterday. What else can I tell from this drawing that is congruent?
That the line in the middle is congruent to itself.
There we go. That line in the middle is congruent to itself, right? By using the reflexive property, I know that if this line here is shared between the two, that line is congruent to itself using the reflexive property. So now look here. I've got a side, I have an angle, and a side. Does everybody see that? I can prove that these two triangles are congruent because I can see that I've got this side is congruent to this side, this angle is congruent to this angle, and this one is congruent to itself. I'm gonna turn it so y'all can see when I'm pointing at the board. Okay. So by using side angle side, I can prove that these are two congruent triangles. Perpendicular bisector cuts the segment in half. Therefore, I know these two are congruent. I know that this side is congruent to itself. I know that this is a 90-degree angle. Therefore, this will be a 90-degree angle. So these are congruent using side angle side. All right, let's look at example 1, using perpendicular bisectors. In the diagram shown, we have line MN is the perpendicular bisector of segment ST. Letter A says, what segment lengths in the diagrams are equal? Okay, so let's look at that first. So what do we know are equal so far? What are the marks they've given us to show that they're equal?
T and S.
Okay, we see that T to N and N to S are going to be congruent because they've given us those hash marks, right? All right, and so based on the other part that they've given us, what else does it show is equal? Okay, so I can see that I've got that angle there, so I could come over here and know that that angle would be 90 degrees. What else have they labeled and told us is equal to each other? Okay, I can see that this side is 12 and this side is 12, so they told us those are equal. So here's my question. When I'm looking at this, if this side is 12 and this side is 12, what kind of triangle is this? If two sides are congruent or two sides are equal,
Isosceles?
I have an isosceles triangle. What do I know that if the two sides are congruent, what do I know about these angles? What do I know about the base angles?
If the base angle is equal, then sides are equal.
Okay, well, we know the sides are equal, therefore my base angles are equal. Okay, so that's the converse. Remember, one of them says if my sides are equal, my base angles are equal. The other one says if the base angles are equal, then the sides are equal. They told us that these sides are equal, therefore I can deduce that it is an equal, it's an isosceles triangle. Therefore, I know that I have my two base angles are going to be congruent. Okay. Same thing if we look at what do we know about our other two small triangles? About these two right here. We've already said that these two are congruent, right? So what do we know about these angles right here?
They're right angles.
They're going to be right angles because we know that perpendicular intersection forms 4 right angles. And then what else do we know by looking at this figure?
That the base angles are equal to each other, so side.
Since their base angles are equal, it means their hypotenuses are all
Okay, now think about this for a minute. How do I know? Remember, base angles, that means my two bottom angles are going to be congruent. So is this one congruent to this one? No, so these are not congruent base angles. So I don't have isosceles necessarily. So remember, I can only assume what they have told me to be. They have not told me that these are two equal sides, but how do I know they would be congruent? What other piece of information do I have?
The bisector.
This line here from M to N is shared between these two triangles. So I can see there that this line there, because of the reflexive property, that MN is equal to MN. Therefore, notice that I have side, angle, side. So by using side, angle, side, I know that these are congruent. And then it says to explain why Q is on line MN. Trace real quick, and let's look at our figure. How do I know that point Q would be part of line MN?
Because the line has arrows going out and it's never ending.
Awesome. Because I have those lines going, I know that this is, let's try that again. I know that that is going to be an extension. When I see the arrows, I can see that extension goes out. Therefore, Q is also part of MN. Okay. All right, let's move on to the next page, page 266. Using properties of bisectors. Okay, so it says the distance from a point line is defined as the perpendicular segment from point to the line. Okay, so the length of the perpendicular segment, from the point to the line. Okay, so it says, for instance, in the diagram shown, the distance between point Q and the line M would be QM. So basically, let's see. So we can see that when we're talking about those distances, so it says when a point is the same distance from one line as it is from another line, then the point is equidistant from the two lines. When the point is the same distance from one line as it is from another line, then it is equidistant from the two lines or rays or segments. It could be a line, it could be a ray, it could be a segment. The theorems below show that a point in the interior of an angle is equidistant from the sides of the angle if and only if the point is on the bisector of the angle. Okay, so let's take a look at these theorems. Theorem 5.3 is the angle bisector theorem. So if I hear angle bisector, what does the word bisector tell me? Cuts it in half. So if it's an angle bisector, it's cutting an angle in half. If it's cutting the angle in half, what do I know about the two angles that have been formed? They're going to be equal to each other. Good. Okay. So it says, if a point is on the bisector of an angle, then it is equidistant from the two sides of the angle. So look at this. Because this is the bisector, these two are congruent angles here and where we have angle A cut in half. So because this is the perpendicular bisector, now I know that from the bisector to each side of the original angle is the same distance, what they drew in blue. So I can see that from B to D, it's going to be the same distance as it is from D to C. So the converse of that tells me that if a point is in the interior of an angle and is equidistant from the sides, then it lies on the bisector of the angle. So first of all, if I have the bisector of an angle, equidistant from the two sides. If it is equidistant from the two sides, then it's an angle bisector. Okay, so those are our bisector theorem and then the converse of that. So it says a paragraph proof of theorem 5.3 is given in example 2. Exercise 32 asks you to write a proof of theorem 5.4. So let's go ahead and look at example 2. They have told me that D is of angle BAC. So I can see angle BAC, that's my big angle, BAC. They've told me that D is on the bisector. Because of that, I know that my interior angles have been cut in half, so they are congruent. I know that the distance from D to B is going to be the same as D to C. I also know that when I have my perpendicular bisector, when I look at my sides, when my sides intersect with my angle, when I'm looking at this right here and this right here, notice that that intersection point makes right angles. Okay, so when I'm looking at the distance from the bisector to each side, 90-degree angles are formed along those two sides. So again, in this situation, we're trying to prove that DB is equal to DC. And so it says by the paragraph proof, it says by the definition of an angle bisector, angle BAD is congruent to angle CAD. We talked about that just a minute. That BAD and CAD, that these two angles here are congruent. Because angle ABD and angle ACD are right angles, then we know that angle ABD is congruent to angle ACD. Okay, so we're talking about our right angles, so those are now congruent. So I've shown that this is congruent and this is congruent. Okay. Lost my place. By the reflexive property of congruence, we can see that AD is congruent to AD. Okay, so I can see that these reflexive property tells me that those are congruent. Then triangle ADB is congruent to triangle ADC by the angle side congruence theorem. So let's take a look at this a little bit closer. Remember when we're doing side, angle side, angle side, angle side, angle, what we're looking at is they have to, basically if I'm traveling around the triangle, they have to be next to each other, or they have to go in that order, okay? So like I couldn't jump here and say, hey, I've got angle, side, angle. This side here in the middle from C to A would have to show that it's congruent to be able to use angle, side, angle here. I could not use angle, side, angle here because I have not proven that these two angles are congruent. Here is I've got angle, angle, side. Okay, so because I was able to prove that my interior angles are congruent, this angle here is congruent because it intersects at a 90-degree angle, and then these sides are congruent, then I can use angle, angle, side to prove that these are congruent triangles. Okay. All right, example 3, using angle bisectors. So we're showing a roof truss, and it says roof trusses. Some roofs are built with wooden trusses that are assembled in a factory and shipped to the building site. In the diagram of the roof truss shown below, you were given that ray AB bisects angle CAD, and that angle ACB and angle ADB are right triangles. Okay, what can you say about segment BC and segment BD? So I'm going to focus in just on this part right here. I don't have to necessarily worry about this part back here. So what they just told us, you were given that ray AB bisects CAD. So that means this part right here bisects CAD. Change my color. Okay. Yes.
In the bisector, will it always be congruent to itself, or will it be times where like it's not congruent to itself?
So you're talking about when I use a bisector, is it always going to cut something in half?
I'm saying when you use the bisector, it's always gonna be congruent to itself. It's like it's always.
Yes. So you're talking about actual AB right here. So if that's my bisector, using the reflexive property, AB is always congruent to AB. So you know that you've got a side that's congruent to a side. You can always assume that whenever it is sharing a side for two triangles, you can always prove that AB is congruent to AB using the reflexive property. Okay, that's the reason we learned that in the very beginning. Is for us to be able to recognize that if I've got two triangles sharing the same side, the reflexive property tells me that those two sides are congruent. Okay. So now we can see, let's see what it was the other given. Because it's a bisector, we know that angle A was cut in half. We also know that when that bisector intersects those two sides, they intersect at 90-degree angles. Okay. So in this particular situation, let's see, it says, what can you say about BC and BD? So if I'm looking at what I'm trying to figure out is what can I say about BC and BD? Okay. What do I know based on what we just talked about? Okay, that's congruent to AB. And what is that? It's going to be a side, right? Mm-hmm. So I know I'll label that as a side. What else do I have as congruent?
90-degree angles.
Okay, my angles are congruent. So those are angles, right? Mm-hmm. What else do I know is congruent? So I've labeled this side as congruent. These angles are congruent. What about these angles in here? Those are congruent angles. Okay,
So would it be angle side?
so we look at this. We've got a couple of things here. I can use angle side to show that they're congruent. And so if those are congruent, then I know that CB and DB are also congruent. Okay. So that says that because BC and BD meet AC and AD at right angles, they're perpendicular segments to the side of CAD. This implies that their lengths represent the distance from point B to AC and AD. So remember, we talked about because those are bisectors, then I know that, remember we just talked about back in theorem 5.3, that if we have a point on that line, I'm sorry, not 5.3, if we have our perpendicular bisector theorem says that if we have a point that's on the bisector, then it's going to be equidistant. So if B is on this bisector, then I know that from B to C, that's going to be the same distance as B to D, because B is on this this bisector line. Okay. So let's go ahead and look at our practice here. It says if D is on the blank of AB, then D is equidistant from AB. So if we know that D is on the blank of AB, then how do we determine that D is equidistant from AB? Remember, this is all going back. Remember, this is kind of the purpose of the notes. What did we just learn? That if a point is on the blank of AB, then it is equidistant. What definition did we learn that tells us this? That if a point is on the blank of AB, then it is equidistant. This is going to be in our theorems.
Angle bisector.
Or close, not angle bisector. No, we're not dealing with angles. Nowhere on here did it say anything about an angle.
Perpendicular.
Perpendicular bisector, good. So if D is on the, then we know that D is equidistant from AB. Okay. Look at number 2. Point G is in the interior of angle HJK and is equidistant from the sides of the angle JH, JH, and JK. What can you conclude about angle G? And it says use a sketch to support your answer. So let's go ahead and look at this for a minute. Okay, so it says point G is on the interior of angle HJK. So I'm going to draw angle HJK. So HJK. And they said G is on the interior. So that means I've got point G. And it is equidistant. Hold on a second. And they said that it is equidistant from the sides. So that means there and there. I know my drawing isn't perfect, so it's not going to be exactly proportional. I've drawn my angle. Point G is equidistant from each side. So what can we conclude? And it says JH and JK. Okay, so that was the equidistant sides. If I know that point G is equidistant from either side, then what do I know about the line that point G is on? Wouldn't that have to be a bisector? Okay. So if it tells me I've got a point that is equidistant from each side, I know that it's going to be on a, the bisector of that angle. It'll be an angle bisector there.
So G is an angle bisector.
G is a point on the angle bisector. Okay, so they only told us G was a point, but that it was equidistant from either side of the angle. So if it's a point that is equidistant from the sides of an angle, then it lies on the angle bisector. Okay, so it says in the diagram, line CD is the perpendicular bisector of AB. So we're going to look at this little diagram here. They've told us that CD is a perpendicular bisector of AB. So look at number 3. It says, what is the relationship between AD and BD? It's fine.
Not both 90 degrees.
Now, notice what it's asking us. What does this symbol right here mean?
Line.
Okay, remember that segment. Remember, if it has arrows, it's a line. If this has just a line like that with no arrows, it's a segment. We'll come back to this in a minute. Go ahead and take a break.
I was confused on number 2.
On number 2?
I didn't really understand that.
Okay, so basically, let me pull this back up real quick, sorry. Okay, so based on what they told me, let me erase this and we'll redo it. Okay, it says point G is on the interior of angle HJK and is equidistant from the sides of the angle. So the first thing I'm going to do is I'm going to draw angle HJK. Okay, so I have HJK. Are you good with that? Oh, I'm sorry. Sorry. When I turned it off, it stopped sharing. We've got angle HJK. Are you good? Well, come on. There we go. They've told us I've got angle HJK. Okay, and they said that point G is in the interior. So that means it is going to be inside this angle. Okay, and not only did they say it's on the inside of the angle, but they said it's equidistant from this side. From my point is going to be equidistant from this side and this side. So I know that my point is going to be right there in the middle. This is based on what they just told me. They told me that G to H, let me change this color real quick. They told me that from here to here and from here to here, and again, my drawings are not going to be exact. They told me that those are going to be equidistant. So that's those two sides are congruent. Okay. Therefore, if I have an angle, I have a point on the interior that it is the same distance from G to H as it is G to K. What do I know, or what can I conclude about this point right here? They've already told us it's equidistant. So what else can I conclude based on, so now look back at your theorems. Look at theorem 5.3 and 5.4. Look at those drawings. When I have that point that is equidistant from side to side, what kind of line is that lying on? The bisector line, the angle bisector. So I can conclude that if they're equidistant from either side, then I know that G lies on the angle bisector.
There's kind of like an invisible line.
Exactly. Yes. Yes. So you're having to kind of see something that's not there. Okay. So that, to me, that's the hardest part about geometry, is you're having to see things that they are not explicitly telling you. But I can tell that point G is going to be on the bisector of this angle right here. Therefore, these two angles are congruent. Does that help?
Yes, so you're saying HJK, no, HJG is equal to JK. JK, I think.
Yeah, so HJG would be congruent to, you could either name it as KJG. So now you've got that angle bisector. So now we know that now these are two congruent.
It into two angles.
Uh-huh. Yeah, and so now we already had that these were congruent. Now we can see that this is going to be congruent to itself. And then we now know that those two angles are also congruent.
Okay.
And the hint there is that if they say use a sketch, it's going to help you to draw it out.
Yeah.
Draw it out and label what you know. And so that's what I tried to do in yellow. And blue, I tried to add those sides congruent.
I'm pretty visual.
Yeah.
So when I try to do this in my head, I'm like, I don't get it.
Yes.
You know what a quarterback really sucks? I remember. I was in just a kid. I'm scared all. I mean, it's so funny. I was like, during like all this out, I don't think people swim. And I'm like, okay. And then what about Auburn? Like, what about Auburn? I said, I don't know if everything breaks out. And like, players in your team, I'm like, I'm like, I'm like, those it's just like, dude, Alabama shut out state, and I'm like, yeah, he stayed.
Okay, let's see, which questions are
Yes,
on?
let's take a look.
I just need
Once they
to.
say they leave, they're-
Okay, so basically, if we look at number 11, so these are our options, side, 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 what does that mean?
Usually like 75.
Side.
If it's side, side, side congruence, that means that this side, this side, and this side. Okay, that 7, 8, 9, 10, 11, and 12, your answer should either be side, 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 angle, side, angle, side, angle, 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 side, or angle, side, angle, split. So look at number 9. Look at 7, 8, and
I thought
9.
yours was.
Okay, yeah, but if you look at number 7, so you said, is it possible to prove that they're congruent? And you said yes, because you have side, side, side. Okay. It's gonna be yes or no, and this is going to be the reason why. Okay, so, based on what we just talked about, look at number 8. What else do I know is congruent in that figure? Okay, these two sides are congruent. Okay, what are those? Are those sides or angles? Huh? Okay, so FH is going to be congruent to FH, right? So these are gonna be hypotenuses, right? So I know that if the hypotenuses are congruent, and this leg is congruent. Mhm. So what does that mean? I changed to? Look at number 9. Okay, what do I know is congruent here? Okay, so. Give me a second real quick. On this one, write an S there, and an S there. Or the side there, there will be D. Okay, so this is how you said side, 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 okay? Here, go ahead and write an H for each of these. And then an L for this one, so you can see how hypotenuse leg. 2 things called, where my boxes are. Okay, they're angles, right? So just put A's over those. That's an angle, that's an angle. What are these called? Angles or sides. Okay. Okay, is there anything else that I can conclude is exactly the same? Did they tell me that? I have to assume that, right? And I cannot assume. On this, I could conclude because this is congruent to this is congruent to this, and by the reflexive property that's congruent. So I had side, side, side. Here, they told me my hypotenuses were congruent, and I concluded by the reflexive property, these are congruent. So can I tell that those 2 are congruent? Nope. Okay, look at number 10. What can I conclude here? But, I mean, congruent with the arrow. It means they are parallel. So these 2 sides are parallel. These 2 sides are parallel. What do we know about when I have a line that cuts through the parallel? What an angle is. So look back at.
Lucas, do you have any accent noise in shoes? Yeah. I would choose,
Okay. Do you remember how when we looked at when I have my parallel lines
Australia.
and I have a line going through, what can I conclude about my angles? Remember all that? So basically, if these are parallel lines and this line is cutting between them, what do I know about my alternate interior angles and things like that? So that's what you've got to think about there. Okay. Here, what do I know about these 2? Okay, and they are what? Sides are angles.
Oh, sorry.
Okay, label them. What do I know about these 2?
Yeah.
Okay, what are they? Remember, angles are cut inside. Okay.
I swear.
What
Did you
Now, what do I know about this line?
Yeah,
The line being an angle.
that Daniel plays music a lot more on ROG. I swear.
He does.
He always, he has it low,
Huh?
and he literally, I can see his.
Well, no, I don't have a right angle, so I cannot assume it's a right triangle, therefore I don't have a hypotenuse. What do I know about this line?
I read it. I visited them. He
How many
told me
sides does a
that
triangle
He
have?
probably watching the video.
Wait,
he told
How
me
many
that
sides
it
does a
was
triangle have?
like he didn't say
Three, okay, so I want you to look at this figure, where the. Where's the other? No, okay, like, so I have a side here, and a side here, and a side here, right? So these are my sides of this triangle. For this one, these are right here.
because her threats were.
That's a side, right? Is it equal to itself? Yes. So, if this side is equal to itself, and this side is congruent to that side, how can I determine those are congruent?
Is it by side, side, side angle,
And trust
side?
me, she will. I've known her for years.
What angles did we
She's a
put
cheer
on her?
coach. and
It's 7.2 is not hard.
Like best friends with her family.
Exactly. If you get on the good side.
Get on her good side and she'll like love you. Like she lets me just not use them.
Now look at number
Sometimes,
12.
if I mess up,
What
she's
had they
like, "It's
told me
fine,
or
we can mess it up." She like starts.
Okay,
Yeah,
like,
last time I didn't know the answer and I got crying.
what else did they say are congruent?
I have her analogy.
What are those?
My sister just cries like back
Yeah.
Angles.
here. Or something.
What else do I know is
Maybe
congruent?
emotional.
What is it? What is it?
Yeah.
In the middle of class.
Is it a side or an angle?
It's Alex.
Okay, label it.
Alex.
I mean, my sister did the same thing.
So,
Alex.
which of these can I use if I have a side and an angle, a side?
I've had like
Have to look and see what is congruent. Now, on this one,
Yeah, I'm
what did we learn about exterior angles in my two
I'm
interiors?
sorry. It's just
And then they're like, are you okay? Do you understand? And I'm like, no.
Yeah.
My
Look
sister.
at that one.
It's so
We
weird,
both-
cause I'm.
All righty, let's go ahead and pick back up with our practice. We looked at number 2, we said that, and it told us, and so if it says to draw a sketch, you're gonna need to draw a sketch to help you figure it out, okay? So it said that we've got little HJ, that G was on the interior of it, and that with it being on the interior, it is equidistant from each side of the angle. Therefore, because we know that it's on the interior, it's equidistant to each side, then remember that there's a class next door, so that, yeah. So we can conclude that it's on the bisector of that angle. It's on the angle bisector, okay? Now let's look at 3 and 4. They've given us our diagram. And it says that CD is a perpendicular bisector of AB. Therefore, we know that it intersects at right angles. And so it says, what is the relationship between CD and CD? So if I'm looking at AD and BD, what do I know about those two sides? If CD is a perpendicular bisector, what do I know about the measure of those two sides? They're congruent, right? AD is equal to, or is congruent to, AD is congruent to BD. Now it says, what is the relationship between angle ADC and angle BDC? So this is where, good, they're both going to be 90-degree angles. So we know that angle ADC equals 90 degrees and angle BDC equals 90 degrees. Therefore, angle ADC is congruent to angle BDC. And then it says, what is the relationship between AC and BC? And it says to explain your answer. I can't just give it and be done. What do I know about these two sides?
Both the legs of the hypotenuse.
Well, they're not, okay, so legs of a hypotenuse, legs and the hypotenuse are two different things, okay? They are the hypotenuses of a right, but what do I know about AC and BC? What are their measures going to be? AC and BC will be congruent because those are not, remember, reflexive means that this is equal to itself. AC and BC are two different things. They can't be equal to itself.
Perpendicular bisector theorem.
Okay, so based on the perpendicular bisector theorem, what did we learn about point C? If you look at theorem 5.1 and 5.2 on page 265, If I'm looking at C, how can I conclude that those two lines are congruent? What theorem?
Perpendicular bisector theorem.
Okay, but what is that? So it tells me though, that because of the perpendicular bisector theorem, that that point is equidistant from the endpoints of the segment. My endpoints are A and B. Going equidistant. Therefore, those two sides are congruent. They did not tell me they were congruent. I have to understand that because I have a perpendicular bisector, and I know that theorem 5.1 says that a point on the perpendicular bisector will be equidistant. Okay, let's look at 6 and 7. It says in the diagram, PM is the bisector of LPN. So let's go ahead and just look at this. Based on that knowledge, let's go ahead and diagram this picture. They told me that this is a perpendicular bisector. They have already marked my right angles. What else do I know to be true about?
PM is congruent to itself.
Okay, that's going to be congruent to itself. What else do I know? What do I know about L and MM?
You can use that postulate perpendicular bisector theorem.
I know that LM and MN are going to be congruent because point M is on the bisector. Therefore, from this point to this, it's going to be equal from that side. So we know congruent. What else do we know about the angle LPN? What do we know about this big angle? What do I know about each of these? If I know that PM is the vector due to LPN, due to this angle right here, cuts it in half. So what does that mean about these two angles? They're equal, they are congruent. They're going to be the same measure because it's a perpendicular bisector. And automatically know these sides are congruent because my point M is equidistant to either side. I know that my angles are going to be congruent because they've been cut in half because it's an angle bisector. So let's look at the questions they ask us. What is the relationship between LPM and M? Okay, so they said, what is the, so I'm talking about these angles here. Remember, we've got to pay attention to what they're telling us. So they're saying, hey, what is the relationship between two angles? We already identified before they even asked us. We already said, hey, I know that they are congruent. So I know that angle LP PM is congruent to angle NPM. How is the distance between point M and ray PL related to the distance between point M and ray PN? So now we're talking about these two right here.
Is there anything significant about it's all like the entire angle LPN is a right angle, like it's the big angle
How do you know it's a right angle?
because it has the angle. If you look at it from the right, if you look at it from the side.
But is it marked?
Yeah.
You cannot, it does not have a box in it. So you cannot assume if it does not have a red box drawn in it. I know that this is a right angle because they identified it by a red box. I cannot assume that this is a right angle right here. It could be less than 90 degrees. This could be 89.5 degrees. It could be close to 90, but I cannot assume that it's 90 degrees because they did not put a red box there. Okay, so remember, well, it looks like it would be, or it looks like it would be congruent. I have to have a theorem or a postulate to be able to state that it is definitely, and it has to be marked. Okay, but what do I know about LM and NM? They're congruent. We had already even marked that before we even looked at the questions. Understanding the relation, if you understand that first, then you're going to be able to answer the questions much more easily. If you look at the drawing and kind of diagram it and break it down before you even try to answer the questions, we had already answered these questions before we even answered them. So we said that ML is congruent to hold up, what did I just do? What is the distance between point M and PL? Yeah, okay. So we know that ML is congruent to NM. Or I guess we would be better to go ahead and say LN. All right, so let's go ahead and look at our homework for this section.
On 14 and 15, we used to on pages.
Hold on just a minute. Okay, so let's go ahead and look at 8 through 10. We'll be doing number 9. The directions say, tell whether the information in the diagram allows you to conclude that C is on the perpendicular sector of AB and explain your reasoning. So it's going to be yes, it is, or no, it's not, and this is the reason why. Okay. 11 and 13. Tell whether the information in the diagram allows you to conclude that P is on the bisector of angle A. So number 9, you're dealing with perpendicular bisectors. 11 and 13, you're dealing with angle bisectors. If it is, tell why. If it is not, tell why. Let's look at number 17, using perpendicular bisectors. It says to use the diagram below to answer the question. Same thing with 19, you're going to use the diagram. Page 9.
So what does it mean on 17? Find SR. Why do you find what SR is congruent to?
It says in the diagram, line SV is perpendicular to RT, but VR is congruent. See what you can conclude to find the measure of SR. And then I want you to go ahead and do 21 through 26 on page 269. So we're going to do on page 268, we're going to do 9 odds.
But not 15.
Not so you can mark out number 15, 9 through 19 odds, but not number 15. And then I want to do 20 through 26 all on page 21, 22, 23, 24, 25, 26. Now notice you have A, B, C, D, E, and okay, so you're looking to see the angle measures in segment. Page 268, 9 through 19, but not number 15. Page 260, 21 through 26. All right, let's go ahead and turn the page to 272. Bisectors of a triangle. Okay, so we've already looked at that. Now we're looking at bisectors of a triangle. So it says in 5.1, you study properties of perpendicular bisectors of segments and angle bisectors. In this lesson, you will study the special cases in which these segments and angles being bisected are parts of a triangle. So it says a perpendicular bisector of a triangle is a line or a ray or a segment that is perpendicular to a side of a triangle at the midpoint of the side. A line, ray, or segment that is perpendicular to a side of the triangle at the midpoint of the side. What do I know about a midpoint of a side? That midpoint equals middle. Diagram here of my perpendicular bisector in my triangle. If they said that this is a perpendicular bisector of this side, I know that it is bisecting at the middle of that bottom leg. It's bisecting the base. So the perpendicular bisector, remember, it is not going to bisect perfectly at the other points that it goes through. All right. So let's go on down to the bottom of the page and look at the examples they've given us. When 3 or more lines or rays or segments intersect in the same point, they are called concurrent lines or rays or segments. This is when they intersect at the same point. Okay, intersect at the same point, they are called concurrent. The point of intersection of the lines is called the point of concurrency. So concurrent is where they intersect, is that they all intersect at one point. That specific point is called the point of concurrency. Look at our acute triangle. It says 3 particular bisectors of a triangle. Every triangle is going to have 3 bisectors, okay? Because there's 3 lines, because there's 3 sides, I can bisect every triangle 3 ways, okay? So if we look at this example here of our acute triangle, notice that when that's what this line straight up and down is. I have bisected this bottom.
Are we gonna have to use our protractor for this?
No. So you can see that I have bisected this side. Now this line right here is bisecting this side on the left. This is the bisector here. When I look at this third side, I can see this here. And when those 3 bisectors intersect right there in the middle, that is my point of concurrency that they've labeled as P. When I look at a right triangle, concurrency, what do you notice about it? How is it different than my acute triangle? My acute triangle. In the middle, it's inside the triangle, right? So it is inside. I'll put point of concurrency is inside the triangle. Where is my point of concurrency on my right triangle?
Right at like the top of the middle. Like in the top, I guess is what you say.
Or what do we call that? The hypotenuse. So the point of concurrency is on the hypotenuse. So with an acute, my point of concurrency is in the middle, or is inside my triangle. With a right triangle, my point of concurrency is the hypotenuse. What about the and what about my obtuse triangle? Where is my point of concurrency?
Out.
Outside. So my point of concurrency is outside the triangle. So if you were to see just a diagram with your lines drawn, and you have to determine right or obtuse, you would determine that based on where is that point of concurrence. Is it on the triangle? Is it outside? Is it inside? Or if they said, where would the point of concurrency be located? On an acute triangle, on a right triangle, on an obtuse triangle. Okay, so the point of concurrency can be inside a triangle, on the triangle, or outside the triangle based on what kind of triangle it is. All right, now on page 273, it says the point of concurrency of the perpendicular bisectors of a triangle is called the circumcenter of the triangle. The point of concurrency of the perpendicular bisectors of a triangle is called the circumcenter. When I hear circum or circ, what is that the prefix for? Circle. So when I hear that, I know it's going to have something to do with a circle. The triangle at the bottom of 272, circumcenter is at point P. The circumcenter of a triangle has a special property described in coordinate geometry to illustrate this theorem in exercises 29 through 31, and a proof appears on page 835. All right, we're not going to stress about that right now, but let's go ahead and look at theorem 5.5. Concurrency of a perpendicular bisectors of a triangle. Notice it says the perpendicular bisectors of a triangle intersect at a point that is equidistant from the vertices of the triangle. Equidistant from the vertices of the triangle. What are vertices? Okay. Section. Okay. So notice we're talking about from P to B, from P to A, and from P to C. Okay, so PA is equal to PB is equal to PC. I know that the perpendicular bisectors of a triangle intersect at a point that is equidistant. Now, are my red lines or my blue lines in this example the perpendicular bisectors? Is it the red lines or the blue lines?
Both.
Perpendicular. They intersect at what kind of angle?
It's the blue lines.
It's going to be the blue lines. They intersect at a 90. The only three that are marked 90-degree angles are those blue lines. So my blue lines are indicating my perpendicular bisectors. Okay, so if you need to make a note of that, the blue equals perpendicular bisectors. It's just showing that it's equidistant from point to vertices. Okay, so that's why that's the difference in these red and blue lines. The blue lines are the ones that are forming that point of concurrence. Okay, notice that my blue lines go from a side to the point of concurrence. My red lines are going to the angles, okay, or going to the vertices. So that's the difference here between the red lines and the blue lines. You need to understand the difference of them, okay? My blue lines are my perpendicular bisectors. They are what form that point of concurrence. Using the point of concurrence, I can determine that my distance is the same to each vertice or vertex. And that's what theorem 5.5 says. Okay, so it says the diagram for theorem 5.5 shows that the circumcenter is the center of the circle, the triangle. The circle is ABC. So when I said circumscribe about triangle ABC, that means the triangle. The circle is around the triangle. Let's look at example 1. It says facilities planning. A company plans to build a distribution center that is convenient to 3 of its major clients. The planners start by roughly locating 3 clients in the center of the triangle form. So you can see that they've got their clients mapped out. EF. So they're trying to find, okay, what's going to be in between each of these clients. We want to be equidistant from them. So it says, A, explain why using the circumcenter as the location of a distribution center would be convenient. B, make a sketch of the triangle formed by the triangle. Okay, so you can see that if I was on this map, I would go ahead and draw a triangle from E to F, from E to G, and from F to G. Okay, so we can see that that forms a triangle. If I was using my bisectors of my triangle, I could see that I would, and this is going to be a super rough sketch, so just know that it's not going to be exact. Let me go back. So I know I'd have a line going through there, I'd have a line going through here, a line going through here. So I could see that my midpoint, I'm bisecting each line, and like I said, I know they're not perfect, but it's just to give. The perfect drawing is down here. So we can see how they drew the triangle. Then they use their perpendicular bisectors to determine that point of concurrency in the middle.
So we're not gonna like draw those little lines, 3 lines.
No, it's going to give you the diagrams. This is just helping you to draw a sketch. Remember, a sketch is not it's not to scale. Okay, a sketch is just to help you see it. Just like when I just kind of freehanded that and I just drew it real quick, I could draw my triangle real quick and I could see if I bisect this line here, bisect this side, where they all intersect. So I'm not having to do anything perfectly here. It's just a quick sketch to be able to see it. So then I can see the relationship. All right, so it says because the circumcenter is equidistant from these, each would be equally close to the distribution center. So if I have my distribution center at point D, I can see that it's going to be the same distance from D to E, from D to F, and D to G. And it says to label the vertices of the triangles E, F, and G, draw the perpendicular bisectors, label their intersection as D. So that's what we have seen here. That E, F, and G represent the different locations on the map. By drawing the perpendicular bisectors of each side of my triangle, I find that perfect place where the distribution center would be the same distance to each location. And it says by theorem 5.5, we know that D to E, or DE, is equal to DF, which is equal to DG. All right, so we've been using, right? We've been looking at the bisectors of each side of a other part of a triangle besides the sides, the angles. Now we're going to be looking at the angle bisectors of a triangle. We just looked at the side perpendicular bisectors. Now we're going to look at the, so that told us how we cut each side in half to where each side is congruent. We found the midpoint. Now with angle bisectors, we're going to cut each angle in half. How many angles of a triangle do we have? 3. Okay, there are 3 angles in a triangle. Now we're going to look at the bisectors of each angle. So it says that as an angle bisector, an angle bisector of a triangle is a bisector of an angle of the triangle. The 3 angles are, the angle bisectors is called the incenter of the triangle. So now we have angle bisectors. Going to cut each of those angles in half. There are 3 of them that are concurrent, and the point of concurrency of the angle bisector. Concurrency is when I'm bisecting my sides. in center is when I'm looking at the concurrency of my angles, angle bisectors. Now, the one thing it says here is it always lies inside the triangle, hence the name in center. Remember, our point of concurrency when I was dealing with my sides is it could be inside, on the triangle, or outside. The insert is always going to be inside. Special property that is described below in theorem 5.6. So let's look at the in-center in theorem 5.6. The angle bisectors of a triangle intersect at a point that is equidistant from the sides of the triangle. Okay, so notice when I am bisecting my angles, if I started out with triangle ABC, we're just looking at triangle ABC, and I were to bisect each angle, I bisect angle A and it would come out like this. Okay, and I'll go ahead and extend it just so you can see it. So basically like that. It's going to go like that. Okay, but we can see where those three cross over at this point in the middle. This is called our in center. Now notice, look at my circle formed here. Remember when we did our circle outside a minute ago, we said that it is circumscribed about the triangle, outside the triangle. Now we're looking at our circle inside the triangle. And so it says the diagram for theorem 5.6 shows that the in-center is the center of the circle and touches each side of the triangle once. The circle is inscribed within AB. Circumscribed outside, inscribed inside. Okay, so you're going to need to know those terms. It's going to be on the outside of the triangle. Inscribed means it's inside the triangle. And it says, thus, the radius of this circle is the distance from the center to any of the sides. So think about, we know what the radius of a circle is, right? What is the radius of a circle? What is a radius? It's going to be from any point on my circle, middle. Goes all the way to the other side.
Circumference.
Circumference is radius.
Area.
No, area is going to be this whole in. What do we call if this line were to extend? Diameter. Okay, think about radius and diameter. The radius is half the diameter. And so we're talking about the radius now. Yes. Yes. All right, we've got about 5 more minutes. Let's go ahead and take a look at example using angle. Now we're using MNP, and the angle bisectors meet at point L. What segments are congruent? So let's look at this. Notice that ML is 17. What other measures are going to equal? Can we figure out any? What measures are going to be congruent here?
PL.
Okay, PL is going to be congruent to what?
No. Wait, no.
Okay,
Wait,
I
yes.
can't really tell congruence on that. What can I tell congruence of?
SL, RL, and QL.
SL, RL, and QL. So because I can see that these have right angles, these are going to be my perpendicular bisectors. And that those perpendicular bisectors are all going to be congruent. So that those are all congruent. Okay. Now it says find LQ and LR. So let's look at this. Let's look and see LQ. Bless you. So I need to find that measure there, and I need to find LR. So what information do I know when I'm looking at this triangle here? When I've got this triangle right here, remember, here, I'm trying to find this triangle here. And I need to find my unknown side, QL. What do I know about? What is the measure of that side?
15.
What is this side?
Also 15.
If I know the measures of two sides of a triangle, what can I use to find the third side? If I know two sides of a triangle, how can I solve for the third side? Look at letter B. Use the Pythagorean theorem. What is the Pythagorean theorem? A squared plus B squared equals C
I
squared.
remember that from last year.
Okay, so if I know two sides of a triangle, I can always solve for the unknown side using A squared plus B squared equals C squared, where A and B are the legs and C is the hypotenuse. So if we look at what we've substituted here, they've said that I'm going to have A squared plus B squared equals C squared. I know that my hypotenuse is 17. So again, A, B, and C. I know one leg and I know the hypotenuse, so I have to solve for my. Let's do this. All right. We will pick up with the practice on this lesson. So as of right now, the only homework that we're writing down is from 5-1. We've already looked at. Okay. Now tomorrow, that means we will finish up 5-2, and we're probably going to get 5-3 and 5-4. So know that typically each week we're going to have 4 sections of work. All right. So you've got to figure out schedule-wise how best to map that out for your schedule. Okay. So we will pick up here tomorrow in 5-2. All right. If y'all have any questions, let me know if you need help with anything.
Miss Jennifer, could you say that it was kind of lagging a little bit when you said the first part of the homework? Do you mind going over that one more time so I can write it down real quick?
Is going to be page 268, 9 through 19 odds, but you do not have to do number 15.
Okay.
So eliminate number 15. And then on page 269 will be 21 through 20.
Sorry, which page? That's on page.
And then that'll be it for now. And then you guys, whenever you finish your test, you can either text it and email it to me. You can, or text it or email it. You don't have to upload it. Just either text it or email it to me. Okay.
Okay. Thank
Do you want me to email the homework as well?
Yeah, you can email. It's better for you to just take pictures and send it to me, whatever's the easiest way for you. Okay.
Thank you.
All right. Thank you guys. I'll see y'all tomorrow. Bye-bye. Hello, hello.
This is homework.